Calculus, and our first speaker will be Karl Crisman from Gordon College.
Yes, so welcome. I hope that this projection 4:9 ratio or whatever is correct for those who are filming it. I should also thank the AIBL and EAF for helping me get here today, although I realized I didn't put it on this first slide. So I want to start off by just talking about what we're talking about here, and most of the time I think you're going to be doing a fun activity, or at least I hope you think it's fun. That's the goal anyway. You like to have students really grapple with material, right? You want to have them maybe do some kind of exploration on their own to try and figure out what they're doing, but there might be some external constituencies. And so this is the context that I'm in here. That's one reason why I talk about the dropping things in. There can be a lot of constraints. So some of you guys might have a common text between sections, especially if you're at a larger university. You might have a common syllabus that you're expected to use even if they aren't at the same time between different offerings in different semesters or quarters or whatever. Are there other ideas that anybody has, a significant constraint? And then this is the point where somebody has to bring a microphone to you. Significant constraints on being able to just go for the inquiry. Maybe we'll take that, maybe Mindy. Common exams is one idea. And then we had somebody over there in the green. That was your same thing? Common exams? Okay. We don't have common exams, but yeah.
Expectations of service disciplines?
Expectations of service disciplines. So now you don't need the microphone because I can re-say what he said. Yeah, that's definitely true, and we're going to talk about that. But yeah, there's lots of constraints, right, guys? So I think particularly with calculus, this is the problem. You got the sciences. You got the econ business track. You have math majors. Who knew? You have the general education students, and all of them have different expectations, or whoever is sending them into your class does. Also, and I think this is a very unique thing to calculus, there's this kind of standardized curriculum nationwide. You teach two different linear algebra courses, they could look very, very different. Two different calculus courses probably are going to share about 90% of the content, particularly for Calc 1, right? I mean, that's not universal, but I think that there's a lot more of it in calculus. And again, you might have some other ideas about why calculus is even worse when it comes to this. Now, I'm coming from a very specific set of constraints, which I'm going to share with you. This is not your constraints. So imagine your constraints in place of my constraints. We have a one-semester calculus survey course. What does that course consist of? Derivatives and integrals, but you can't assume that anybody knows anything more than algebra 2. Prepare for both bio and econ majors, but it also has to be something that you can take Calc 2 after having taken. Yeah, this was the first course I taught when I got to Gordon too. So it was like, here's this new course nobody's taught. Have fun. And I have had fun eventually, but it took a while. There's some other constraints too, and these are obviously ridiculous constraints, right? And in practice, you know, we find ways to work with them. We're using the applied Hughes-Hallett text. Because of these other constraints, I can't use just a straight up IBL text, or indeed a lot of the modeling first text. I highly recommend that you look at the MAA's publication. Their new modeling text that's out there is all online. It's a really fun one, but it's just not appropriate for our course. Similarly, we have a very wide variety of backgrounds in the course. Some people who really struggled through Algebra 2, and then others who got a 3 on the AP exam. But it does, you know, we require a 4, and then they're like, I'll take the one-semester survey because that seems easier than taking Calc 1. So it's pretty bad. So if I'm going to do inquiry-based stuff, it has to be something I can just drop into this course without a lot of muss or fuss. Okay? That's the point of today, is what kind of things can we do? And basically, I'm going to give you a few ideas of what I do, and you're going to try one of them. But I just as much want you to tell me things that you have ideas, and I already got an idea from the talk earlier by our session chair of something I could do. And hopefully you can share that with me throughout the rest of the conference as well. That's what I'm here for, is more stuff that I can do. So here's something that we can drop in. This is not really IBL. Warning. This is an example that I think barely qualifies. But it's probably how thousands of classrooms actually do use an inquiry-based idea. So that's the caveat. OK. I introduced the idea of a derivative as a function the day before. So here's my notes. You can read it. I'm not going to read it for you. But so here's kind of how we talk about it in class, okay? So you can get the context of how we're thinking about derivatives. It's, again, very Hughes-Hallett, very reform calculus in style, okay? So that's just for context. All right, so here's what I'm dropping in. They were asked this question a couple days before we get to the activity. Look at average rates of change of x squared, where a equals 1, but b equals 1.5, 1.1, 1.01. And then they compute these average rates of change. They get, the things that you would expect. And then we talk about why is that like looking at the speed at x equals 1. And those who've done reform calculus type stuff with limits of difference quotients, you'll be familiar with this. Okay, now here comes the IBL-ish thing. We estimated the derivative last time, or a couple times ago, depending on how things go. And we got f prime of 1 is about 2. On your own, estimate f prime of 3 and f prime of 5. I know this is really deep stuff, right? But I go around the classroom, we help people, and we kind of say, like, well, what are you doing? Maybe they forgot how to do the difference quotient already since last time. And most of the groups end up getting a kind of a pattern. And of course, some of them kind of know what to expect, but many of them really do get a pattern. They've forgotten. And then I say, well, is there this possible pattern? Depending on how it goes, I talk about it in the group. Maybe I go up to the board and we kind of write down some ideas people have, because sometimes people get too hung up on the 0.001 that shows up in the difference quotient. They're like, the formula is 2x plus 0.001. And of course, well, that's where they're coming from, right? And so we talk about that. And so then I have this formal conjecture, maybe, that f prime of x might be equal to 2x. We don't prove this at this time. Again, is this really inquiry-based learning? It's not more method, let's put it that way. But I think that there's a piece of inquiry in there, and it's something that we can think about in terms of how we direct things. Oh, and here's what the students see, just so you know that I'm not giving it all away to them. There's more space where it says on your own. I give them space in there. So the idea is that I'm giving them a kind of a template. Some of them use it, some of them don't, but I find it helpful. They usually like the handout. So the idea is that you're giving them something. This is the more inquiry-based part, right? They're exploring that in groups. Okay. My claim is that's how you can get a foothold. Now it's your turn. Okay, so I think most everybody has some sort of writing utensil and thing to write on because your conference packets came with these nice yellow pads, right? I was thinking of printing out handouts, actually, and the talk just didn't get written early enough. So you have to use your own pens and paper. But it's really easy because this is going to be a little meatier but can be dropped in. So again, this idea of drop-in calculus, it's just something I plop in basically to replace how I would introduce it in the class. And now what I want you to think about is you might make some mistakes. But if you don't make any mistakes, think about the mistakes that your class might make. Okay? You're not required to make mistakes, but you're required to think about what your students might do. And you should take some time. This is what my students will see. Okay, this is what will be projected as well as in their handout. So sometimes I walk from the train to campus, and so I have this little table of data, time versus speed, d prime, and they already know what prime is. So they kind of know if that's a speed. And maybe somebody's pacing me. They're checking my speed once every 10 minutes just to kind of get some data. So we talk a little bit about how to interpret this table, and I'll skip that for you guys. And then I ask the question, how far was my walk to campus? Assuming this is the only information you have about it. You have these speeds at different times, and it's in miles per hour and hours. You might want to check that it even makes sense. Are these reasonable speeds? 4 miles an hour? How far was my walk to campus? Go. It's okay to not necessarily know what to do right away, yeah. If you want to just think about it first. Before. Because this is the way the students are going to react, right? Wait, what am I asking? So using knowledge you already have from just real life. That's a great question. What a great question. Am I done? And so the students would have asked that, and I would have said yes. But sometimes they're not sure. Like, did I go another 10 minutes after that? And so that's one of the things we talk about, like what's the model? That's right. So go ahead and do it as if I didn't finish. And how did you get this? I don't want a number. I want to know how you got the number.
Well, we said that for each of these little portions.
So for each of them. Mm-hmm.
That was 1/6 of an hour.
Mm-hmm.
So then we said for this first 6 of an hour, on average, let's say you walk 3.5.
So you averaged the speeds to kind of get a rough estimate for how fast I was going. Good. So that's different than some other students. They might just say 3 miles, 4. But you just said, hey, let's take over that whole 10-minute period. Let's average them. Okay? Both of those seem like reasonable suggestions to me. Which one's right? Or is there a right answer? Okay. Well, let's bring the attention back up here. I saw lots of much too accurate answers. You all fail because you did it right. So here's some ways that people do it. These are my actual notes, and so I have class notes. I use LaTeX with Sage built in to make graphs and stuff. So these are my actual class notes. I'd say let's talk about some different approaches. So I have to say, a lot of you guys did this one, right? Average the 2 speeds on each interval and then multiply each of them by 1/6 of an hour. But a lot of people will average all the speeds, all 5 speeds, right? And then they multiply by 2/3 because that's how long I was doing it. And some of us were having discussions, well, how long did I actually walk? And I make it clear, well, I did walk for 40 minutes. And then they have to figure out how to reconcile that. Well, what kind of average do I make if there's 5 things, but there's only 40 minutes? And they have to think about, what does that mean? Some of them will do the equivalent of a left-hand rule or a right-hand rule. Or they might, if they're really clever, they might do both. And then the final thing is you could do the higher or lower. So that'd be like the upper sum and lower sum. Now, not too many groups will do that. And for this particular example, you end up, it's kind of nice, you end up getting the same thing for the left and the right hand. And so that works out pretty well. But the point is that there's many different things that people do. I guess many of you guys know how you did it. I think most of the groups did it one of those ways. Now, here's something that nobody you guys did. But this happens a lot. And this is why I want you to think about these activities.
We did that.
Oh, you did that. Oh, OK. Yeah, you multiplied each. So what they did, let's go back to the actual data. Oh. 0 times 4, 1/6 times 3, 1/3 times 2.5, 1/2 times 2, because they correspond, right? And then I have to say, well, how long was I walking then? The answer is 2 hours. And I was like, oh, and how far did I walk in 40 minutes? They're like, yeah, 5 miles. Is that realistic? No! But this is the kind of thing, right? You have to have your detector on, your detector of not real things. And so how would you respond? And a lot of people brought up conversion of units, and I'm not going to talk about that now, but that's another issue that can come up, is conversion of units, or why did I use fractions and not decimals? There's just a whole host of things to think about. Nonetheless, I think that this is like my most happy land activity where I feel like I did a good job putting it together. It drops in, it fulfills more or less the expectations, and you guys did it in 10 minutes, so you figure about 20 minutes for the students. They can do this, right? This is something that kind of drops in. So that's why I like it. Oh, and then sometimes, if we have time, I reinforce the concept and say, hey, what if we lied? They actually checked your speed every 5 minutes. And then what do? Can they use the same technique? Okay? Sometimes I get to that, sometimes I don't. So here's some points for discussion, and maybe this is where the microphone becomes useful. So what kind of topics might lend themselves to some kind of drop-in activity? I don't really know. Although now I know one more from the previous talk. What topics might not be so good? What kind of preparation might students need for that? How much slower, how much stuff should I not expect to cover by the end of the semester because I'm doing this? Where can you find good resources for this kind of thing? Because the Journal of Inquiry-Based Learning and Mathematics is great, but it's not going to have this kind of activity, at least not yet. So any ideas, discussion? I only have one more interesting slide. So.
Hi, my name is Amanda Matson. I'm at Clark University in Dubuque, Iowa. And I'm going to jump down to your second to last bullet point where you might find good resources that are easy to adapt for such activities. I know Angie Hodge has done a lot of stuff with calculus and activities that can be put in places. So I'm not sure off the top of my head where she keeps it all or if it's published somewhere.
Her, though, yeah.
But talk to Angie about pulling more things in.
That's great, yeah. And I should mention there's also Myreed, I don't know how to say her name, Green, has a whole IBL notes for calculus for a regular calculus course, not like a proof-based course. And that would be another resource. But again, it's an entire 2-semester course. You have another hand over here. So it's the drop-in nature that I'm really curious about, and which is the tail wagging the dog of this talk.
Hello, I am Katie Waddick, and I'm from the University of Nebraska at Omaha. I'm Angie Hodges' student assistant, so I have all of her stuff pretty much. We have a Dropbox folder that we put everything. So if you ever want to contact her or me, our names are both in the email list, and we can send them to anyone who wants it.
Because it'd be great to have a whole repository of things like this, yeah. Other ideas or discussion? Or should I just go to the next couple slides? Well, keep on thinking about it, because I want you to find me at this conference. I fly out at 11 tomorrow night, so I'll be here for a while. Oh, I hope it's clear. This is like just my first attempts. This is what you would call preliminary discussion, right? This is not the final product. Why is that? Oh, other activities. So here's some other ideas, just so you think I don't have only 2 activities. Some of them I use more often, some I don't. Well, anyway. So can you discover the derivative of sine and cosine from the graphs? So we do this, but I don't really have them do it. I just kind of I say, hey, here's the graph of sine. Where's the derivative 0 here? You know, can we graph? And of course, they've all forgotten how to graph derivatives by this point, because we do it like in November or something. And they graph derivatives in September. But so that's kind of, I could turn that into an activity. What does average speed mean? This is actually the very first day of class. I asked them some questions about speed and distance, and we discovered what average speed is. One thing we discover is that average speed could be in miles per hour, or it could be in hours per mile, or minutes per mile, because it depends on the context. And that we just decide we're going to do it in miles per hour, where that's like the input variable. This is one that I like to do, and it's the last slide, so I'll put it up at the end. Can you use tables to discover differentiation rules for like f plus g? Or a constant times f. So there are some ideas. And now here's my thanks. Thank you for coming. This is a great turnout. I'm so happy. Thanks to the organizers and the Academy of Inquiry-Based Learning, for whom I have now promised to create and class test more such activities. But maybe I can just borrow Angie's, and then I don't have to do any work. So that'll be great. Many, many authors of calculus resources. I've gotten so many wonderful ideas. And most importantly, I have to thank the hundreds of students that I have tried these activities on in the MAT 134 Survey of Calculus. I've probably taught 90% of the sections of this class that have ever been offered at Gordon. And so I think they're heartily sick of me and my activities. And so I'll leave that up for you to think about as we take other questions.
Okay, can we please first thank our speaker?